Miss Jennifer, I had a quick question about something.
Okay, hang on just a sec. What you got?
So I'm still printing my pages out. I have like page 10 and stuff, but page 11 and 12, like lesson 11 and 12, they haven't printed out yet. My printer's having trouble. I've gotten everything else printed out though.
That's fine, because we're going to be starting by reviewing. We probably won't get that far today. We'll be looking at reviewing lesson 7 and working on 8. We'll be doing review of our study guide and things like that. So it'll be fine.
Okay.
Miss Jennifer, I tried to send those pages that you told me to, but we have really bad Wi-Fi.
Okay.
And like they wouldn't deliver or whatever.
Okay.
So
did you try to email or do you want to text them? If you want to text them, you can.
Okay, I tried to text them too, but it's not loading.
That's fine. Just as soon as you can. That's fine. I'll know that they are on their way.
Okay.
Grab a cough drop real quick. Wait on everybody else. 1, 2, 3, 4, 5, 6, 7, 8, 9. Come on, 5 more to join. Everybody have a good weekend? Anything great and exciting?
It was pretty good.
Pretty good?
Yeah, we just stayed home. My dad went out of town because he had to go help another church out in Georgia, so we just stayed home and watched TV all weekend.
Yeah. That's always good to have a weekend like that. Let's see. We got Kinsley and Evelyn. We have Claire and Mark and Grant and Richard and my King sisters and waiting on Zoe Owens and Katy Perry. That's Katy Perry. Jonas. Got Sadie and Zoe and Micah. So we said we're waiting on Zoe Owens, Katy Perry, and Jonas. All righty. So we'll get ready and get started in just a minute. A couple of things. Here comes Jonas. The first things that we're going to talk about is about homework, because I know that there were several of you that I emailed with homework missing assignments and things like that. So we're going to talk about that. Then we are going to go over our study guide that we had for homework. We will go over that. We will talk through any questions that we have to be prepared for the test. I will email you guys the test this afternoon, and then that will be due on Thursday, and then we will keep moving right along. Okay, so let's see, as we say, Zoe Owens and Katy Perry, it looks like are the only ones that we're missing now. So hopefully they'll jump in just a minute. So if you don't have your study guide with you, go ahead and get that. And then we'll talk about homework for just a minute. And I want to be sure that I answer any questions that you guys have. I know that if you have, it's my understanding that if you have already uploaded work, you can't upload more or something. I'm not real sure. And some of you may be able to help me with that. So that's why with, if I've asked for a page, like as I went through assignments, I realized that maybe you uploaded, maybe if we had an assignment that had 4 pages, you uploaded 3 of them, but you didn't have 1 of them. And so maybe I sent you an email saying, hey, I'm just missing this page or whatever. Now there were some that if I was missing a whole day, there'll be a place to upload them still. So I just want to make sure to answer any questions that you guys may have about homework uploads. Making sure that you remember that they are due the day, by class time each day. So like today, if I were to look right now, I should be able to see homework, and I can do that real quick. Let me go ahead and share my screen real quick. And then I'll kind of show you what I'm looking at, and then that way, if y'all have questions, y'all can ask, because I know a lot of times my screen may look different than your screen does. So let's see, I'm gonna go here. So when I go into the Homeschool Life tab, get logged in. Okay, so when I get to my tab, I can look at my current classes and I look at Algebra 1, and then I can go and look at my assignments. So today, our current homework, remember the place to upload is going to be to the effort tab, okay? So then what I can do is once I look at that and I look at my submissions, I can look and see who all has uploaded to the effort. Now, usually what happens is if I see a gap there, then I'm going to go and I'm going to look back at the accuracy tab because sometimes I might find it there. So know that if I don't see it one place, I'm going to go look in the accuracy tab, okay? And, oh, that's the wrong date. I did the 13th. Here's today. Today is the 24th accuracy. Submission. So then I go there. Okay, so I'm noticing that some people are posting on accuracy, some people are posting on effort. It doesn't matter. Okay, don't stress about that. Just put it in one of them. Okay, I'll find it. So, so that's what I noticed in going through homework this week. If you put it somewhere, I'm going to find it. Okay. The main thing is it just needs to be one or the other. Is everybody good with that? That if you, it doesn't necessarily have to be effort or accuracy, just put it in one of them. Okay. Here comes Zoe Owens. Any questions on that? Okay. So what, one of the things that I worked on last night,
Am I just here early, or is it starting yet?
do what?
Am I here early, or is it starting now?
No, we start, I mean, this class starts at 10:20.
Okay.
So what we were talking about is I was going through homework submissions and stuff like that, just making sure that we answer any questions about that. So everybody's good. Right now, I'm being super lenient and trying to be relaxed and everything because I know it's going to take a little bit of time to get it all sorted out. Okay, so right now I'm not taking points off for late assignments and things like that. Later on in the year, I will be. So that's why I'm wanting to take this time now to make sure that everybody knows where it's to be posted, your timeline for posting, and then so like one of the things I want you to realize is last night or this weekend, it took me a while to get everything graded for the 13th and the 17th assignments. Fortunately for the 13th, I think it was just like one page or something. For the 17th homework, we had 4 pages of homework due. Okay, so there's 14 students in the class, and so I'm going through 4 pages for 14 students, and so I would find that I was missing 1 page for one student and a different page for another student and a different page for another student. So I was trying to email you guys and say, hey, you're missing this page. If you can't figure out how to get your missing page uploaded into the system, that's okay. Take a screenshot or take a picture of it and text it to me or email it to me. Okay, so if there's anything you're missing that I've asked for, you can email it to me if you can't get it to upload in the system. Any questions about that?
No, ma'am.
Okay, in the future, just not right now, but in the future, that will be something that that will end up taking points off because that's the effort part of it. So if it's not uploaded, if everything is not uploaded on time, then that would lose points. Okay, so that's why I encourage you and Next week, can y'all believe that next Monday, hopefully, fingers crossed, we'll be in the classroom. And so that's why I recommend you using this sheet to write down your homework. And so you can see, if y'all can see it. So it's where I've written down the assignments, and then I have over here due date, okay? So that way today, when you write down your assignments for whichever lesson we're talking about, you can write down your homework and you know what the due date is. That way you've got a concise list of everything that's due, so you don't go, was it this page or did I have that page? Or when you're uploading your homework and taking pictures, you're able to see exactly every single one, okay? Any questions about that?
Yes, ma'am.
Awesome. Okay. Now, the next thing I want to do is let's go ahead and take a look at our study guide. Okay, so go ahead and pull out your Unit 1 study guide. This is going to be what we are working on with our test. All right. So the first one, kinds of numbers. We found that natural numbers or counting numbers and start with the number 1. Please be sure to check your study guide. If you've missed something, you don't want to study the wrong information for the test, so make sure to make corrections. The next one, whole numbers are natural numbers and the number 0. Integers are the positive and negative whole numbers. When you hear the word integers, picture a number line in your head. Rational numbers are numbers that can be written as a fraction. These include decimals that either terminate or repeat. If you put repeat first, then terminate, it's fine. Irrational numbers are numbers that cannot be written as a fraction and include decimals that do not terminate or repeat, and imperfect square roots. Any questions on section 1, kinds of numbers? All right, section 2, signed number rules. Now, if you look, I emailed you guys homework back from 8/13 and 8/17. Now is the time for you to look back at that homework that I sent you for those dates, because there were several people that really need to brush up on these signed numbers, okay? You need to look and see, did you miss more than you got right on your homework on signed numbers? If so, study these rules for the test, okay? For addition, when adding two numbers with the same sign, add like normal and keep the sign. So if it's a positive plus a positive, you're going to add them together, keep the positive sign, keep the plus sign. If it's a negative plus a negative, add like normal, keep the negative sign. When adding two numbers with opposite signs, take the sign of the larger number and find the difference of the numbers by subtracting the smaller number from the larger number. So take the sign of the larger value, subtract the 2 to find your answer. For subtraction, when subtracting signed numbers, change from subtraction to addition by changing the minus sign to a plus sign, and then change the sign of the number following. You do not change the first number. I noticed on some people's homework, you change the first number, then you change the sign, and then you change the sign of the next one. Don't change that first number, okay? Keep the first one exactly like it is. Change the minus sign to a plus sign, and then take the opposite sign of what is following that, okay? Here comes Katy Perry. Okay, multiplication and division. When multiplying or dividing two numbers with the same signs, your answer will always be positive. When multiplying or dividing two numbers with opposite signs, your answer will be negative. Okay, Katie, we are going over the study guide. We're on section 2 with multiplication and division. And then the last one says, when multiplying more than two numbers, count the number of negative signs. An odd number of negatives will give a negative solution. An even number of negative signs will give a positive solution. So again, look at the homework that I emailed last night, or actually I guess it was this morning. I think I finally shut down around 2 a.m. grading papers. So I emailed out the things I had graded. look at those. Look to see what you missed and why you missed it, okay? The only way that you're going to get better at a skill is by identifying what you made a mistake on and learning what to do differently, okay? So especially signed numbers, there were several of you that really need to make sure you're reviewing these skills. Any questions on signed numbers before we move on? All right, exponents. Exponents tell how many times to multiply a number by itself. Any number except for 0 raised to the 0th power equals 1. Remember, if it's to the 0 power, my answer is 1 every single time. If it's 5 to the 0 power or 5 million to the 0 power, my answer is 1. When multiplying terms with equal bases, you're going to add the exponents. When dividing terms with equal bases, subtract the exponents. When a product of 2 or more factors has an exponent, you can either raise each individual factor to that exponent and then multiply, or you can multiply the factors first and then raise the product to the exponent, okay? That's the example, like if I have 2 times 3 in parentheses, and outside parentheses it's to the 2nd power, I can either do 2 squared times 3 squared, or I can multiply 2 times 3 is 6 and then do 6 squared, okay? I can either do them each individually, or I can multiply and then raise to the exponent. When a number has a negative exponent, take the reciprocal of the number and make the exponent positive. Remember, if you see a negative exponent, you need to be thinking about flipping the reciprocal, okay? Again, that was something that I saw that some people need to review on. I think some of you just like, I saw some that just didn't even get answered, and I guess y'all got to it and said, oh, I don't know. Remember that we've covered all this in your textbook. So as you're going through this work, if you get to something that you don't know how to do, flip back to the lesson, okay? That's also why I encourage you to take notes. If you have notes, you can look back at your notes that you've taken to help you remember how to do something. But use your textbook. Don't just not do something. Look back to learn what to do, okay? That's what your textbook is for.
Miss Jennifer?
Yes.
There was one, I forgot which one it was, but I didn't know the answer, and like I looked back and I still couldn't find the answer, so I just didn't answer it.
Okay, so always be sure to let me know if there's something like that. Y'all know from having Horizons for Pre-Algebra that we saw some things, we saw typos in the book, we saw some things that maybe weren't covered or whatever. So if you run across something like that, please, please, please shoot me a text. Say, hey, I've looked and I don't know what to do here, okay?
Okay.
I just don't want you to get it, I don't want you to get it marked wrong because you don't have it. So I don't want you to miss that point. So let me know if you need help. Thank you for letting me know that. Let's see. The last point on exponents says, when a number has a negative exponent, this is what we just said, take the reciprocal of the number, make the exponent positive. If the exponent is outside parentheses, make sure to apply the exponent to both the numerator and the denominator. So outside parentheses, I have to raise the numerator and denominator to that power. If there are no parentheses, then I keep the exponent with whichever number it was with in the very beginning. It is just now made positive by using the reciprocal. Any questions about exponents? Okay. Order of operations, parentheses or any other form of grouping. We talked about how even sometimes with absolute value that can be considered an order of grouping. Brackets, braces, all that good stuff when we see just some way of grouping. So that's always going to be our starting point. Parentheses, exponents, multiplication, division, addition, subtraction. If there's multiplication and division or addition and subtraction in the same problem, complete them in order from left to right. Number 5, factors are numbers that divide into another number with no remainder. Number 6, prime numbers are natural numbers whose only factors are 1 in itself. The smallest prime factor is 2, and it is the only even prime factor or prime number. Number 7, composite numbers are numbers greater than 1 that are not prime. And number 8, prime factors are the prime numbers that divide into the number with no remainder. So when we do prime factorization, number 9, that is the process of finding all of the prime numbers that multiply together to get the original number. Any questions about prime numbers or prime factorization? Does everybody feel fairly comfortable about primes? Remember though that if you do a factor tree or you use the ladder method or whatever, make sure that you write out your answers as a list of prime factors. Also, I made a note on some papers that maybe you didn't put them in order from least to greatest. I'm not going to count off on that. I just want you to know that that's standard form, that you need to, when you're listing your prime factors, you want to go in order from least to greatest. Remember, if there are any repeating numbers, you can list them as exponents. And so there were several of those that I made notes on your work. But if you have questions about the notes that I've made on your work, please be sure to let me know. All righty. Number 10, moving on to absolute value. The absolute value of a number is the number's distance from 0 on the number line. Since distance cannot be negative, an absolute value will be positive. If there is a negative sign in front of a value, if there is a negative sign in front of an absolute value symbol, that means you will need to find the opposite of the absolute value of a number, so the answer will have a negative sign. So if the negative sign is inside the absolute value, you're going to have a positive answer. If the negative is outside the absolute value, you're going to have a negative answer. Any questions on absolute value? And remember, in absolute value, we may be dealing with absolute values and positive and negative numbers. So we're having to kind of remember, okay, what are my rules about positives and negatives? What are my rules about absolute value? And I put those together. Number 11, finding greatest common factor. Step 1, find the prime factorization of each number. Step 2, circle the prime factors that are common to each number. Step 3, multiply those common factors together to find the greatest common factor. And then 12, step 1, again, first the step, find prime factorization of each number. But in this step, we want to express them as products or as exponents, okay? So if we have more than 1 2 listed, I want to list it as 2 to the whatever power, okay? So I want to make sure to express them as exponents. Step 2, for each prime factor listed, put a box around the one that has the greatest exponent. And step 3, multiply the boxed factors together to find the least common multiple. So any questions on greatest common factor or least common multiple? Any questions on any of the study guide? Okay, so I will be emailing the test out this afternoon. The test is due Thursday, okay? So by class time on Thursday, you should have the test uploaded. Remember, tests are done independently, not looking back at notes, not looking back at your textbook, not asking for help. If for some reason something happens and you do have to ask for help, I just need an email from parents to let me know that you had to get assistance with it, okay? Then that, huh?
Can we use calculators or no?
Can you use calculators? Sorry, I just sucked down my cough drop. We are in algebra now. You may use calculators, okay? You can use calculators. Yay. Any other questions? Evelyn? Do you have a question or not, Evelyn?
I don't.
You don't? You're just waving.
No, I don't know what I was doing with my hands.
That's fine. Any questions? All righty. So we've gone over homework. If you have any missing assignments that you need to send to me that I have emailed you about, I did also put notes in the system, and I don't know if it automatically emails out when I put a note in the system about a missing assignment or whatever. So you may have gotten multiple emails about missing an assignment. So anyway, just make sure to get me those missing assignments. Missing assignments, study guide. I think that's about it. Okay, so now what we're going to do is we're going to go ahead and start taking a look at our homework. Let's check homework. Alrighty, so our homework for Thursday, we had our study guide and then page 16 all. So let's go ahead and take a look at our answers for page 16.
Oh, you didn't tell me to do that.
Alrighty, so page 16, section 3 started out with, do what?
You didn't tell me to do page 16 when I asked what I was supposed to do for homework because I was knocked out of the Zoom.
Oh, did you not watch the end of the video, or?
You said circle this and do this for homework, but page 16 was not one of those things.
Okay, so go ahead and get caught up on that. Let me mention to make sure, and I apologize for that, but so you'll need to get caught up on page 16 and I'll know that it'll be late being submitted.
I'll circle it and I'll send this.
Yeah.
I'll do it now.
Okay. So the first section was solving roots. Next section is absolute value. And then activities 5 is adding and subtracting positives and negatives. And I will go ahead and mention, if something happens and I'm not able to tune into class, or you get kicked out for some reason and you miss something, always know that the video is there for you to go back and take a look at to make sure that you've covered something. I know there's a lot going on, and I will go ahead and tell you that even when we start back in class, our method for homework submission will stay the same. Okay, so even when we meet in class and you have homework due, I'm still going to be looking for it to have been uploaded on the website. I think it'll just be easier to remain consistent since we're in class one week and back virtual the next week and in class the next week. There's going to be too much confusion if you go, oh, I didn't think I was supposed to submit my homework this weekend, or oh, I thought I was supposed to do it this week, or whatever. We will still submit homework just like we've been doing, okay? So know that even next week when we meet in class on Monday, whatever homework we have assigned on Thursday needs to be uploaded to the site by the time you come to class on Monday, okay? All right, so let's go ahead and take a look on page 16. In activities 3, we'll go left-hand column and then right-hand. So starting at the top of the left-hand column, the square root of 36 equals 6. The second one, the cubed root of 8 equals 2. The square root of 12 equals 2 times the square root of 3. The cubed root of 24 equals 2 times the cubed root of 3. The square root of 6 plus the square root of 6 equals 2 times the square root of 6. 3 times the square root of 7 plus 2 times the square root of 7 equals 5 times the square root of 7. And then 2 times the cubed root of 15 plus 5 times the cubed root of 15 equals 7 times the cubed root of 15. Questions? Any questions on the left-hand column? Anything that needs to be repeated? Anything you missed and you don't know why and you'd like me to work it? Okay, let's look at the right-hand column. 8 times the square root of 10 minus 3 times the square root of 10 equals 5 times the square root of 10. 7 times the cubed root of 2 minus 4 times the cubed root of 2 equals 3 times the cubed root of 2. The square root of 10 times the square root of 5 equals 5 times the square root of 2. You may have left it as not simplified. You need to reduce that. You need to simplify it to 5 times the square root of 2. 4 times the square root of 3 times 3 times the square root of 2 equals 12 times the square root of 6. The square root of 32 divided by the square root of 2 equals the square root of 16, which equals 4. 15 times the cubed root of 16 divided 3 times the cubed root of 2 equals 10. And then 5 divided by the square root of 5 equals the square root of 5. Questions on the left-hand column? Any of those that you missed and you would like me to work? Everybody feeling pretty confident with radicals? So remember, the main thing is that I'm always looking to simplify a radical. Even when I come up with my final answer, what I think is the final answer, I want to go through my steps of simplification to make sure that I do have it in simplest form. Dealing with radicals is very similar to dealing with fractions. Remember, anytime I have a fraction, I want to make sure it is reduced to simplest form. Same thing with radicals. All right, the next section, dealing with absolute value. Excuse me. Left-hand column, then right-hand column. So on the left-hand column, the first one, the absolute value of 8 minus the absolute value of 17 is -9. The opposite of the absolute value of 24 plus the absolute value of -7 equals -17. The opposite of the absolute value of 51 minus the absolute value of -28 equals -79. And then the absolute value of 73 minus the absolute value of 57 equals 16. Any on that left-hand column that you missed and you would like me to work? Okay, right-hand column. The opposite of the absolute value of -35 minus the absolute value of -18 equals -53. The absolute value of 91 plus 18 plus the absolute value of 33 minus 27 equals 115. The opposite of the absolute value of 42 minus 26 plus the absolute value of 25 minus 37 equals -4. Then the opposite of the absolute value of 19 plus 14 minus the absolute value of 37 minus 28 equals -42. Any questions on the right-hand column? Any of these you would like me to work? If you missed these, please make sure to go back and correct them. Look to see why you missed what you missed. That is the only way that you're going to get better at something, okay? If you just go, oh, too bad, missed it, that's not going to do you any good for the test, okay? And it's not always just about the test. It's about what comes after Algebra 1, geometry, what comes after that, Algebra 2. If we're not learning these basic foundational skills, then as you continue to go through your math career, it's going to be much more difficult to do these things. So learning them now is going to make math so much easier for you in the future. All right, and then the bottom section is dealing with just adding and subtracting positives and negatives. Multiplying and dividing as well. Okay, left-hand column. -48 plus +53 is +5. -39 plus a -15 is a -54. +93 minus a -65 is +158. -117 minus a -68 is -49. -13 times +4 is -52. -36 divided by -2 is +18. Any questions on the left-hand column? All right, right-hand column. +121 plus +31 is +152. +95 plus -137 is -42. -93 minus a +65 is -158. +117 minus +68 is +49. Then I have 5 times -2 times 13 is -130. And -108 divided by +9 equals -12. Any questions on any of those? Okay, so be looking. If you missed a majority of those, go back through your signs. Go back through your study guide where we wrote out the rules for signs, okay? This is just one of those things where you just have to memorize it. You just have to memorize those rules, okay? Any questions before we move on? All righty, let's go ahead and turn to lesson 8. Lesson 8 is on page 17. Let's see. All righty. So these are dealing with algebraic expressions, okay? So we're going to kind of get into some terms and understanding what these words mean. The first one that we're going to talk about is a polynomial. And a polynomial is an algebraic expression. If that term contains 2 or more terms, the terms must be separated by a plus or minus sign. All variables must have a positive integer as an exponent, and no variable may appear in a denominator. So these are our rules for a polynomial, okay? What I'm going to do is I'm going to go ahead and number these rules, okay? So 1, the terms are separated by a plus or minus sign. 2, variables must have a positive integer as an exponent. So I'm going to put that one with a different. Variables must have a positive integer as an exponent. Then number 3, no variable may appear in a denominator. Okay, so these are our rules for a polynomial. All right, so now we get into the word constant. A constant is a number that has no variable. So if we were talking about -1, 3, 0, okay, these are all examples of constants. Constants are terms that are numbers without variables. They're just numbers. Think about the word constant means always. It's never changing. It's the same time after time. Whereas a variable can be, if we have the variable a could be any number. It could be an infinite number of numbers. Whereas a constant, a -1, is always a -1. It's not sometimes a 5 and sometimes a -1. It's always a -1. Okay, so that's why it's called a constant, because it never changes. A coefficient is a number that is multiplied by the variable. So when I talk about if I have 2a, the coefficient here is 2 because it's a number with a variable, -3x, okay? So it's the number that it's still a number, but it is in front of a variable. Now, one of the things I want to mention here is that if I have a number in front of a variable, that the understood operation is multiplication. That if I knew what the variable was, I would multiply those two together. So 2a actually means 2 times a. -3x actually means -3 times x. We just write it in a more simplified version since I'm dealing with a number in a letter. It's just easier to go ahead and write them side by side and understand that it indicates multiplication. Is everybody good with that? All right, the next one is a monomial. Think about the prefix mono. Mono means 1. Okay, so a monomial only has 1 term. So they've given us some examples. X squared, 3x, 5, only have 1 term, so that is a monomial. Mono meaning 1. A binomial is a polynomial containing 2 terms. Notice over here, 3x plus 5 is a binomial because I have 2 terms. X squared minus 4x is a binomial because there's 2 terms. The way I can tell they're different terms is because of the plus and minus. Remember back up here where it says in number 1, where we put rule number 1, the terms must be separated by a plus or minus sign. That is how I can tell different terms apart, is because they are separated by that plus or minus sign. Okay, so when we see a binomial, I know I have 2 terms here because I only have 1 plus sign or 1 minus sign. Trinomial, 3 terms. So you can see here, x squared minus 4x plus 3. You can tell that these are 3 separate terms because they are each separated by either a minus or a plus. So I'm able to tell. So it says identify whether or not each expression is a polynomial. For each polynomial, identify it as a constant. Remember, that's just a number without a variable. A monomial, 1 term. A binomial, 2 terms. Or a trinomial, 3 terms. Okay? So let's think about our rules first of all for a polynomial. Terms have to be separated by pluses or minuses. Variables have to have positive exponents. And no variables in the denominator. Those are our 3 rules for polynomials. So let's look at the first one. And I have x squared plus 2x minus 1. It is a polynomial, and it's a trinomial. First thing, if I look at x squared has an exponent, and it's a positive exponent. Remember, that's my rule. My exponent has to be positive. Each individual term is separated by a plus or minus. And I don't have a variable in my denominator, so I'm good with that. It is a trinomial, and it is a polynomial. It's a trinomial because we've got 3 separate terms. All right, let's look at the next one. It has 4x to the negative 2nd power. Right there, that throws it out because I cannot have a negative exponent. Because what would happen is, remember, to make a negative exponent a positive, what I would have to do here is that would become 4 times 1 over x squared minus 3x plus 7. I would simplify that, and 4 times 1 is 4, so now I have 4 over x squared minus 3x plus 7, and that messes up with rule number 3 that says I can't have a variable in the denominator. So if I have an exponent that is negative, to make that exponent positive is going to put that variable in the denominator, and I can't have that. Okay? So no immediately, no negative exponents, no variables in the denominator, and you'll be good. Any questions so far? All right, let's go ahead and take a look over here. So we've got about 7 minutes till break. Okay, so don't let me forget it. All right, classwork. It says identify whether or not each expression is a polynomial. For each polynomial, identify it as a constant, a monomial, a binomial, or a trinomial. So the first one, I have 6x minus 4. Thumbs up, thumbs down. Is it a polynomial? Thumbs up, thumbs down. If it is a polynomial, thumbs up. If it is not a polynomial, thumbs down. Look back at your rules. Let's take a look. Do we have terms separated by a plus or minus? Yeah, we're good with that. Do we have any negative exponents? Nope, so we're good with that. Do I have a variable in my denominator? Nope, so we're good with that. So it is a polynomial. Now we've got to determine, is it a constant, a monomial, binomial, or trinomial? So I'm going to look, and I can see that I've got 2 terms separated by a negative sign. So 2 is the word binomial. Okay. Let's look at the next one. The number 17. I only have 1 term. Okay. So I don't have any plus, I don't have multiple terms separated by a positive or negative. I don't have any negative exponents. I don't have variables in the denominator. So thumbs up or thumbs down, is the number 17 a polynomial? Okay, let's look over here real quick at their different types of constants, coefficients, monomials, binomials, trinomials. What is a constant? A constant is a term. Now, what I want you to look at is the fact that it is a constant, so it is a polynomial. Okay? It is an algebraic expression that is a number, which is a constant, so it is a polynomial. Let's look at the next one. 4x squared plus 5 divided by x minus 3. Uh-oh.
Isn't 17 a monomial too, or not?
Yes, we could call that a monomial because it says, it says in the book, a constant is a monomial. So we could call it constant and monomial. Very good. 4x plus 5 divided by x minus 3. Thumbs up, thumbs down. Okay, look at our rules for polynomial. They have to be separated by plus and minus. We're good there. No negative exponents. We're good there. But I cannot have a variable in the denominator. I have a variable that is a denominator, so this is not a polynomial. Okay, that variable in the denominator messes it up. And then look at the next one.
17 a polynomial?
17 is because it's a constant. Okay, so basically the word polynomial is an umbrella term that includes, do you remember how we talked about how real numbers included rational, irrational, whole numbers, integers, everything fell under that umbrella? Same thing with polynomial. Polynomial is my term that describes constants, coefficients, monomials, trinomials, binomials. Okay? So notice it says that it's an algebraic expression. It says if that expression contains 2 or more terms, then we have to follow these rules. So if it says if it does, then that means it can just be a one term, and a one term that is just a number is called a constant. Okay? So constants, monomials, binomials, trinomials, they are all examples of polynomials. And then we have 3x to the negative second power minus 5. Thumbs up, thumbs down. Is this a polynomial? Okay, a big thumbs down because we have a negative exponent. I cannot have a negative exponent, so it is not a polynomial. And then finally, I have 3x squared minus 4x plus 2. I have more than one term separated by positive and negatives. That's a check. I have an exponent, but it is positive, so we're good there. I don't have any variables in my denominator, so I'm good there. So yes, it is a polynomial. What kind of polynomial?
Trinomial.
Trinomial, because it has 3 terms. Very good. Any questions on how to identify polynomials, and are they monomials, binomials, trinomials? Go ahead and do activities 2 right now on your own. Activities 2, identify if it is or is not a polynomial. Is it a monomial, binomial, trinomial, or is it a constant? Okay. Go ahead and do that right now. Activities 2 on page 17. I should see everybody working on that. When you're finished with that, you can go ahead and take a break. We'll take our 5 minutes and then come back and check them.
So are we gonna go over more like about the roots and radicals today?
We will talk more about that, Millie. Shh.
I'm glad your dog's feeling better.
Thank you. Yes, she's feeling better, but then that means that she is going to bark at every truck that goes by. All right, so let's go ahead and get ready and go over these activities. Make sure everybody's back. Okay, so on activities 2, we are identifying whether or not they're polynomials, and if they are they constants, monomials, binomials, or trinomials? So in the first one, I have 9x minus 4. Thumbs up if it's a polynomial, thumbs down if it's not. All right, I see some thumbs up. It is a polynomial, okay? Thumbs up, it is a polynomial. Remember, we've got to look at these rules to determine, are there more than one term, and are they separated by plus or minus? Yes. Is there a negative exponent? No. Is there a variable in the denominator? No. So that means it is a polynomial. And it is a polynomial, and there are 2 terms, so that is a binomial. Okay. The next one, 7x squared plus 3 divided by x, ding, 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 red flag, minus 4. Okay, we had some red flags there because I have an x in the denominator, so this is not a polynomial. Okay. I hope that you can get to the point where you're just constantly able to immediately recognize these. 8x to the negative second power, ding, 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 red flag, red alert, okay? You should be able to see this and go, hey, this is a problem. It is not a polynomial because there is a negative exponent. The number 31, we talked about, it is a polynomial, and we call it a constant, which is also a monomial because it's only one term. 10x squared minus 13x plus 6. All right, terms separated by pluses and minuses. No negative exponents, no denominators with variables, so it is a polynomial, and it has 3 terms, so it is a trinomial. Now we have negative 3x, okay? I don't have more than one term, so I don't have the pluses and minuses, so that's fine. Now, I have a negative coefficient, but not a negative exponent. So that is the big difference here, is that the negative is with the 3, which is what we call the coefficient. And so we have a coefficient with a variable, so yes, this is a polynomial, and it is a monomial. Any questions about any of these, about how to identify a polynomial? Remember, major red flags, variables in the denominator, negative exponents. Those are my red flags. If they don't have either of those, then I'm just looking through, making sure I've got pluses and minuses, looking at all that good stuff. Any questions on that? All righty. So let's go ahead and take a look on page 16. No, not 16. Page 18. Okay, so that was page 17, going on to page 18. This looks kind of familiar from page 16, at least section 3 is dealing with roots again. We're going to continue practicing with roots, okay? But what I want to do, I'm sorry?
I've already done this.
Okay, if you've already done it, fantastic. You're a step ahead. So, page 18, what we're going to be looking at before we talk about this is I want to talk about the rules for radicals, okay? And what I'm going to do is actually I'm going to share, Zoe, what we worked on earlier. Let me find that note from today. All right, it's some terrible handwriting, but hey, it'll has the information. If you are a note writer, that's fantastic. If you want to copy these, the more you write something down, the more it gets into your brain. If you want to flip back to page 15 in your textbook, all this information is also written there. What I've done is I've just kind of put it in step-by-step number form to help you remember. So if you're working with radicals and you get stuck on something, look back, okay? So rules for radicals. I have this broken into simplifying, adding and subtracting, and then multiplying and dividing, or multiplication and division. Okay, so I've got 3 sets of rules here. The first one is simplification, or simplifying, because you need to know how to simplify, whether it's just simplifying or if you've added or subtracted, you still need to be able to check your answer to simplify. If it's multiplication or division, you still need to check your answer to make sure it is in simplest form, okay? So rules for radicals. And I will be happy, I will email this out to you guys today, okay? Let me go ahead and email that to myself, so I'll make sure to send it to you guys. And it'll be rules for radicals. I always recommend writing things in your own handwriting. It just gets it in your brain better. There's just something about it. So anyway, I will send that to y'all after class. Okay, rules for radicals, simplifying. Step 1, list the radicand as the product of prime factors. We are going to list the prime factors for our radicand. So let's go ahead and look over on page 18. Let's do that for the number 25. For the very first one, for 25, what are my prime factors of 25? It's going to be 5 times 5, isn't it? Okay. And so let's see. What I'll do is I'll go ahead and go right here real quick. So we said square root of 25. List it as prime factors, 5 times 5. So that's step 1. Okay, let's go back to step 2. Use the index to determine the number of buddies and circle those buddies. Remember, buddies are a Jennifer Fountain term. This is a non-scientific mathematical term, okay? But basically, you're grouping the numbers, okay? So we have to use our index. Let's look at our index. Remember, my index here, it is not written. I have to understand that it is a 2. If there's nothing there, that means it's a 2. And that means I have to have 2 numbers in a group, or 2 buddies, and I circle them. Okay? So that is step 2, is to identify our buddies and circle them. Now I'm going to go back to step 3. Write the answer. Oh, that's not the right page. Okay, step 3. Each buddy group comes out from under the radical as a whole number. If there is more than one whole number, multiply them together. Any ungrouped radicands stay under the radical and multiply if more than one. So let's take a look here. In this situation, When I circled those two, remember the square root of 5 times the square root of 5 is the square root of 25, and we know the square root of 25 is the whole number 5. So these two buddies are able to come out as one whole number group of 5. Okay? Let's look at what would happen if I have the square root of 75. Let's think about prime factors. I'm going to start with my smallest prime factor, which is 2. 75 is not even, so I know it is not divisible by 2. So I'm going to try 3. And I know that 3 times 25 is 75. Now I'm breaking down 25 into prime factors, and we just saw that 25 would be 5 times 5. Okay, so that's our step 1, is we listed our prime factors. Step 2 is going to be to do our buddies. I have 2 5s that are buddies. Okay, step 3, I'm going to pull those 5s out as a whole number group. But notice the square root of 3 has to stay under the radical because he does not have a buddy to be grouped with. He cannot come out from under the radical sign. Okay, so 3 steps to this: prime factorization, buddies, and then pull it out. Now let's look at what if I had the square root of 150. I'll help you through this one a little bit, but I think you'll find that it's really not that difficult. Start with my smallest prime factor, which is 2. 150 is even, so I know it is divisible by 2. All right, 2 times 75. Hey, we've already factored 75, so I'm going to have 3 times 5 times 5. Remember, if I ever am not sure if I've done this correctly, I know that I've got 2 times 3 is 6. 6 times 5 is going to be, what did I do? 30, and 30 times 5 is 150. I kept wanting to say 300, but I was like, it is not 300. So 2 times 5 is 6, 6 times 5 is 30, and 30 times 5 is 150. So now I have got my buddies here. They come out as my whole number, but notice what's left under my radical sign. I have a 2 and a 3. Those are both prime factors, so I know that, and there's nothing that they can buddy up with. So that means I have to just multiply them together underneath the radical. Now I'm going to throw you one more loop, or curve, or whatever you want to call it. What if I had 2 times the square root of 150? This is going to equal 2 times the square root of, I already have my prime factorization, so I'm going to go ahead and just put that in there. 2 times 3 times 5 times 5. Okay? I have a whole number on the outside. He doesn't just go away. He still has to be there. Okay? So I still have to keep that whole number there that was in there in the beginning. So now when I go down here, I still have my whole number that I had in the beginning. I've got these buddies that come out as a whole number. So now that means that I'm going to put it on the outside of the radical. That means I have to multiply those together. So now I can multiply my whole numbers. 2 times 5 is 10. Then I multiply 2 times 3 is 6. So there is my final answer. So this kind of takes us a progression through these different types of things. If I'm able to buddy up everything, I'm just going to have a whole number answer. If I can find buddies, but I have something left under the radical, then I'm going to have a whole number and radical answer. If I have more than one thing left under the radical, I'm going to go ahead and multiply that together for the solution. Or if I have another whole number on the outside, or if I was able to pull more than one whole number out, I multiply them as the whole number, and then I go ahead and multiply what's under the radical. So these are all examples of simplifying. Questions? Any of this that we did that you're just not quite sure about still? The main thing is, I think one of the hardest things to me when I was doing math was always getting started. Okay? A lot of times I would sit and look at a problem and go, I got nothing. I don't even know where to start. And that's one of the things, that's why I like to give you the steps to say, this is where you start. Because a lot of times if we can just get started on something, if we can just get started, then we go, oh yeah, now I know what to do. Or sometimes we get stuck again. And that's why I want to give you this list of things. You've got a place to get started. You've got a place to look to when you get stuck and look at what you need to do, okay? So that is simplifying. Prime factorization, buddy them up, see what needs to come out as whole numbers and what stays under the radical, okay? Any questions on simplifying? All right, now let's look at what happens when I add and subtract, okay? Adding and subtracting. Step one, my first thing I need to ask myself when I have an addition or subtraction problem with radicals is when I look at each term, is the index the same for each one? Remember, my index is that little bitty number that's above the radical, so sometimes it's a square root, so I understand that it's a 2, or if it's a cubed root, it's going to have a 3. So when I talk about the index, I'll go ahead and make a little note right here. Index, square root, cubed root, okay? So I'm looking at, excuse me, I'll put, let's do this. It might be there, or it might be there, okay? I'm looking to see, are they the same? If they are not the same, I cannot add or subtract, okay? But if they are the same, then I'm looking to see that the index is the same and the radical is the same. And actually, let me change this word real quick to radicand. Let's see. Oh, where's my eraser? I want to change this to radicand. Okay, so I want to make sure my index and my radicand is the same. Remember, my radicand is what is underneath my square root symbol. So if I have the square root of 15, my radicand is, oh, that looks like the sign. It's going to be that number, okay? So I want to make sure my index is the same and my radicand is the same. So that's step one. I'm checking to see if I can even do the problem. Step two is then I'm going to add or subtract the whole number to the left of the radical, okay? Remember, if there is no number written there, I understand it to be 1. If there is nothing there, I understand it to be a 1. So look back on page 16. Look at your homework, activities 3, page 16, where you had the square root of 6 plus the square root of 6. There was not a whole number written in front of that radical. So I had to understand that it was a 1. The reason that 1 is not written there is because 1 times the square root of 6 is the square root of 6, okay? We don't have to write it. That's just like if you had a problem and you had, 1a. We don't, when we're dealing with variables, we don't write the 1 in front of the variable a. We just understand that that would be 1 times a, okay? So if there's not a whole number there, I just understand that it's going to be a 1, okay? So step 2 says I want to add or subtract the whole number to the left. And then step 3, I want to write the answer where I've added my whole numbers from step 2, and then I want to keep the radical the same. Okay, so what I'm going to do is, let's say I have an example of, let's see, I have 4 times the square root of 11 plus 3 times the square root of 11. That means I'm going to add 4 plus 3, and that gives me 7. And then I'm just going to keep the radical the same, which is the square root of 11. Okay? If it's subtraction, I just subtract. Step 1, are my index and radicands the same? Step 2, add or subtract just the whole numbers. Step 3, keep your radical the same. Okay, any questions on that? All right, and finally, multiplication and division. Now remember, with addition and subtraction, we had to ask ourselves, we had to make sure two criteria were met in step one. Is the index the same, and is the radicand the same? With multiplication and division, it is different in that I only have to make sure the index is the same. So I need to make sure that index is the same. As long as the index is the same, my radicands don't have to be the same. Okay? So once I know my index is the same, I'm going to move on to step two. And I want to I want to combine the radicands under one radical sign. Okay? I want to write each individual one together under one sign. So my example of that would be the square root of 2 times the square root of 3. So that means I would put them underneath and have 2 times 3, and then I would simplify to the square root of 6. I take them from separate radical signs, put them together under one radical sign, and in this situation, I can't simplify. So all I do is multiply it together, and there's my answer. Step 3 says to simplify if possible. Okay, in this situation, I can't. Remember this, so in this situation, it says if multiplying, go ahead and list prime factors. My prime factors are listed as 2 and 3, so that's all I can do. Okay, let's go ahead and look at another example that would be a little more challenging. Let's say I have 2 times the square root of 7 times 3 times the square root of 8. Okay. In this situation, I'm going to multiply my whole numbers. So I'm going to have 2 times 3. And then under my radical, I'm going to combine 7 times 8. Okay. 2 times 3 is 6. Underneath here, I'm just going to leave that 7, and now I'm going to break down 8 into prime factors. 2 times 2 times 2. Find my buddies. That means that group is coming out as a whole number 2. So now I have 6 times 2 on the outside, and I have 7 times 2 inside. 6 times 2 is 12. 7 times 2 is 14. It cannot be simplified any further, so there is my answer. So if I multiply or divide and I have a whole number on the outside, I multiply or divide those whole numbers on the outside. And then whatever's on the inside, I combine them under the same radical, break them into prime factors, simplify what I can by doing the buddy thing. If there's any whole groups that can come out based on buddies, then they come out and they multiply again with the whole numbers. Okay? But this is the most important part right here. Always check to see if your answers are in simplest form. Okay? And the simplest form goes back to simplifying. Prime factors, buddies, excuse me, and then writing your answers. Okay? Since I added notes to this, I'll go ahead and resend this to myself so it'll have everything on there. So I'll send y'all the updated one. If you struggle on section 3 on your homework, pull out this sheet, look at it, see if it helps.
So section 3 is for homework?
I'm getting ready to tell. So actually we're going to be doing sections 3, 4, and 5 on page 18 will be our first bit of homework that we're going to assign.
That's
So
right.
page 18. Let's see. All right, so page 18, we'll have activities 3, 4, and 5. 4 is greatest common factor. 5 is least common multiple. Okay.
When's this due?
Okay, so on Mondays, when is our homework due? Anything that's assigned on a Monday, when's it due?
Thursday.
Thursday before class. If it's assigned on Thursday, when is it due?
Monday.
Monday, yeah. The only case would be if I gave y'all an extra extension or whatever and said, hey, I'm giving you this now, but it is not due until whenever. If that's ever the case, I will make sure to tell you. But always assume that whatever is assigned on a Monday is due by class on Thursday. Whatever is assigned on Thursday is due by class on Monday. So as of right now, you're going to have a test and you're going to have page 18. Okay? And let's check our time. It's 11:44. We have got about 20 minutes. So we're going to move on to one more section, lesson 9. All right, lesson 9 is dealing with variables, okay? So a variable is a letter used to represent an unknown numerical value, all right? So whenever you see a letter written in algebra, you know that that is in place of a number that we don't know what that number is. Sometimes we're going to be asked to solve for that number. That's typically the goal of algebra, is we've got a variable, we've got a letter that's representing a number and we don't know what it is and we want to solve for it, okay? And it says in algebra, X is the most common variable. Most of the time you'll see X. Now, one of the things that I'll mention to you is when you see, at this point, we do not want to use the X as a symbol for multiplication. Okay, when we start using variables, using an X for multiplication gets a little confusing. All right, so for what we want to do now is, let's see, for signs of multiplication, use parentheses or a dot. Okay, so you could have 3 times 2 like that. Actually, looks like I've got it circled. Or you could do 3 times 2 like that. But when you have a letter, a variable and a number, you just write them side by side. So like 2a indicates multiplication, and I don't even have to write anything. Okay, I have to write something when it's 2 numbers. I have to know that I'm multiplying, but I just don't want to use an X anymore. Okay, since that our most common variable in algebra is X. We want to get away from using the X as a times table, as a times symbol. Okay. All right, it says in an expression or equation, a letter appearing in more than one location always represents the same amount. So in that situation, if I have X showing in one place of a problem, okay, so let's do this. If I have X plus 2X, then that means those X's are worth the same value, okay? It always means the same amount. Now, if I want to write 2 different expressions, if I want it to represent 2 different numbers, I'm going to use a different letter, okay? But as long as I have one problem and I see a variable repeat itself, I know that for every time that variable is there, it is representing the same number. Does that make sense? All righty. To write expressions with a variable, let X represent the unknown amount. Use the following rules to translate into a numeric expression. Okay, so one of the things that we're working on here is learning how to translate words into symbols that represent numbers and algebraic expressions. Okay, when I say algebraic expression, I'm just saying a way to show words as a math problem. All right. So if I'm using addition, I'm going to see words like more than, total, sum, increased by, added to, and together. Okay? Those are going to be my terms for addition. For subtraction, I'm going to see words like less than, fewer than, difference, decreased by, and reduced by. For multiplication, I'm going to see words like times, of, multiplied by, product, and increased by a factor of. What I want you to notice here is I've got the word increased by in addition, but increased by a factor of is multiplication. They both have the word increased, but I've got to look and see, does it just stop at increased by, or is it increased by a factor of? Okay, and again, that word of right there, we've already talked about, of means multiply. And then the last one, division. Whoop, not that, I want my highlighter. Division per the letter A, not used as a variable, but if, what's the word I can use? I'll think about it. I'll think of an example for A. The word ratio, remember ratio, we want to picture a fraction. Fraction is division, okay? Quotient, percent, and out of. Those are all going to be key words for division. Okay, so it says when simplifying expressions, combine like terms. This is a big deal right here because I want to combine like terms to be able to simplify. Like terms have identical variables with identical exponents or constants, okay? So when I'm talking about a like term, I'm going to have, let me see where I can write this. So my like terms would be like x, 3x, 4x, whatever, okay? Or x squared, 2x squared, etc. Or if I just had 3, 7, 0, we'll make that a 10. Okay, so like terms. Notice that x, 3x, and 4x are going to be the same because they have identical variables with identical exponents. Remember here, if I do not see an exponent with a variable, I understand that that's to the first power, x to the first, x to the first. Notice here, I've got x squared and x squared. I've got to pay attention to those variables, okay? And then also constants, numbers with no variables, okay? Those are like terms, all right? So I want to combine like terms. Let's say I had a basket, and in that basket, I had a mixture of apples and oranges and peaches, okay? Combining like terms is the same thing. I'd put all my apples together. I'd put all my oranges together. I'd put all my peaches together, okay? I can't put anything together that is not the same fruit. I'm doing that same thing here with my like terms. I can't put a constant with something that has a variable because those are not the same, okay? So let's look at our examples here in classwork. And it says to translate the following words into a mathematical expression. Okay, so what I want to do is I want to think about these for a minute, and we want to identify our most important information. So I have 9 more than a number. All right, obviously I know that 9 is 9, okay? So I'm going to leave that as a 9. More than. What operation am I thinking about with more than? I come over here, if I'm not real sure, I'm going to look, and lo and behold, there it is in addition, the word more than. So that means I'm going to be adding. A number. I don't know what a number is, but so it says, let X represent the unknown amount. So I'm going to have 9 plus X. 9 more than a number translates to 9 plus X, or X plus 9. Now I want you to think about this for a minute, because addition and multiplication are commutative. So it does not matter about the order. Subtraction and division, order matters. So we're going to have to pay a lot more attention when we're looking at the ones that involve subtraction and division. Okay. But so realistically, if we looked at this word 9 more than a number, that means I've really started with my number first. My number came first, and now I'm going 9 more than that number. So realistically, the best way to write this is right there. I would not count 9 plus X wrong because addition is commutative. But let's look at the next one, because it says 6 less than a number, and I know that I'm going to need to pay attention here. So 6 obviously does not change. That is a constant. Less than a number. So let's think about, what does less than mean? Subtraction. Okay, less than is subtraction. My number is X. So let's think about 6 less than a number. Think about a number that is 6 less than a number. Okay, if I said 6 less than a number, did 6 come first and then I took a number away from it? Or did my number come first and then I took 6 away from it? So you've got to think about which one came first. So 6 less than a number is going to be X minus 6, because I have that number first and then I take 6 away from it. Okay, so this is where order does matter. Questions about that? If I see less than, I know that my second number comes first. Okay, like if I said 3 less than 5, then that means I'm going to have 5 minus 3 to find my answer. Okay, now we have a number increased by a factor of 12. 12 is going to stay the same. It's my constant. Number is going to be X because I don't know what it is. Increased by a factor of. This is going to be where I multiply. Okay, so when I think about writing a number and a variable together as multiplication, I'm just going to write it side by side. So that would just be 12x. When I'm writing a number and a variable, my number always comes first. That's why it's called the coefficient. Okay, it comes first. The next one is a number increased by 3. 3 stays the same. Number is X. Increased by is plus. So a number, my number comes first, and it's increased by 3. Now let's look at this next one. 23 decreased by a number. 23 stays the same. Number is X. Decreased by, I know, is subtraction. Let's stop and think about this. Which one comes first? If I have 23 decreased by a number, that means I have 23 first, and then I'm making it smaller by whatever that number is. So that means I have to start with 23, then subtract X. And then the next one, a number multiplied by 5. And again, when I multiply a number and a variable, I just write it as the number first as a coefficient and then the variable, so 5x. Any questions on how you know what to write where? All right, and then let's look at the last one. Simplify by combining like terms. What do we understand that the number in front of x is? If there is no number written there, again, I understand it has a coefficient of 1. So 1x plus 2x is 3x. Okay, I'm able to add because the variables are the same. My exponents of my variables are the same. Now here, I've got 4 plus 3 plus x. So 4 plus 3 is 7 plus, plus x. I cannot combine 7 and x because they are different terms. I've got to use the symbol they've given me, which is the plus sign. Now I have x plus 3x. Those are like terms. And 2 plus 6. Remember, my understood coefficient of x is going to be 1. So for 1x plus 3x, that will be 4x. Plus 2 plus 6 is 8. So 4x plus 8. All right. I'll tell you what, let's stop there. We'll pick up with activities 2 on Thursday. Okay, so you do not have to do any homework with this section. So your homework that is due on Thursday will be your test that will be sent out this afternoon. Okay, so the test is the first thing. And then page 18, activities 3, 4, and 5. Test, Unit 1 test, and then page 18, activities 3, 4, and 5. Any questions about that? Okay, if I did email you about any missing assignments, please make sure to get those uploaded. Like I said, I'm not counting points off right now. I probably will give us another week of getting that settled and getting used to it. And then I'll start next week probably where I'm going to have to start taking points. And I really don't want to do that, but it's one of those things where it's real life. And I try to give you all the benefit of the doubt. If there's something that happens though, if there's, if something's going on, illness in the family, you're sick and you need more time, please have your parents email me and let me know. If you need an extension, I am more than happy to give an extension if your parents let me know that you need one, okay? I know if you've gone out of town, if you've been sick, maybe a family member sick, whatever it is, but I try to kind of, as we go further and further in math classes, I try to make things a little more strict and put a few things more in place, because real life, real world, one day when you have a job and you've got a deadline and you go, oh, I didn't get to it, that could potentially hurt you as an employee, okay? And so I know that you're necessarily not there yet, but this is just to kind of help you start getting there, okay? All right. Well, if anybody has any questions, be sure to let me know. Hang around afterward if you need help with anything, or let me know and we can have a one-on-one Zoom. And then I need to make sure that everybody understands that while we're doing classes, I need to make sure y'all are fully engaged. I need to make sure that you're paying attention to me and to not outside things, because realistically, your grades will reflect it. Okay, so make sure that when we're doing Zooms that you're not doing things that are going to distract other people. That's why I had to cut off the chat system, because the chatting continued on. And so I hate that. And when we're in the classroom, I'm going to be especially strict about it, because people need things to be quiet and calm and focused to learn, okay? And I will not allow you to interrupt anybody else's learning, okay? That's not fair. Your parents are paying for this. Your parents are wanting you to learn. And so I have a responsibility to you to help you learn the best you can. And so I need you guys kind of thinking about that, being respectful of one another's learning and being respectful to yourself. So it's the kind of thing that I think you will see as you go through. When you start looking at your grades, you're going to see what you need to buckle down on. Okay, so some of the grades are entered. Like I said, if you were missing something, your grade right now reflects that has not been entered yet. And so I will update your grades by tomorrow afternoon for anything that you send to me. So if you are behind on anything, make sure that I have it so I can get it sent in. And I hope you guys have a great couple of days, and I will see y'all on Thursday. Okay? All right. Bye, guys.
Thank you.
Thank you.
I don't care.